So more graphs. So this time the edges aren't labeled. So if they're not labeled, you don't have to worry about matching them. Okay, so here's a G and here's a G prime. Is there an invariant to stop an isomorphism from happening? Or can we make an isomorphism? So I'm looking at this. I see a circuit of 3, a circuit of degree 3, or length 3. Do we have any circuits of length 3 over here? No. So no circuits of length 3 in G prime. So that makes it not isomorphic. All right, how about this one? Looks like there's the same number of vertices, same number of edges. So let's just start doing it. I think if I say A, I'll go to T. And then let's continue. So A, the next vertex would be C, and so that would go to U. And then if I would continued on the graph here, I would go to the letter E, and that would go to V. And then if I went to the letter G, that would go to W. And then if I went to the letter B, that would go to X. And then if I went to the letter D, that would go to Y. And then last, I would go to G, whoops, which is that F, or no, that's F, I mean, F, and so then F would go to Z. So yes, there's an isomorphism. And what about these two graphs? There is not. Can you see that the graph G is not connected? Because there truly are two triangles, right? One triangle and another triangle. And then G prime is connected, so there cannot be an isomorphism between them. So here comes the fun part where you just get to be creative. Okay, so I want simple graphs, simple meaning no loops, parallel edges, with 3 vertices. So write all the different kinds, the non-isomorphic kinds. So if I just have 3 vertices, that's a graph. And if I have 3 vertices, that's a graph. And if I have 3 vertices, that's a graph. And if I have 3 vertices, that's a graph. Okay, so what I want to make sure you know is that since this is a graph, one of the 4 that I think are possibilities, that means that this graph would be isomorphic to this graph, right? Because they're the same, one line between 2 vertices, right? So this is not included. So these are the 4 unique graphs with simple graphs with 3 vertices. Okay, so what if we go to the next one? So then if I have, it doesn't say simple, 3 vertices, no more than 2 edges. Okay, so it could be no edges, right? So it could just be that. Or it could be 1 edge, or it could be 2 edges. Now it didn't say simple, so that means I can do loops, right? So I could do a loop and then an edge between those 2, or I could do a loop on 2 of those vertices, or I could do parallel edges between 2 of the vertices, or I could make a loop and then make an edge, so that would give me a degree 3 vertex, and then just have this flying dot over here. And then you might have had the question, can we do 2 loops on 1 vertex? We can. So there we go. Or we could just have 1 loop on a vertex. And I think those are all the non-isomorphic. So those ones do not have similarities between them. Okay, so this is getting a little harder. Simple graphs with 4 vertices. Doesn't say how many edges, right? So I could start off with absolutely no edges, or I could have 1 edge, or I could have 2 edges. And remember, this would be isomorphic to this, right? Because there's 2 edges and between the 4 vertices. So this, you're not going to include something like that because it's can be made in relationship with this one, right? So that's why you have to start making sure you don't have duplicates. So then I could have 3 edges, or I could have 4 edges, Or I could have 3 edges, a triangle, and a flying dot, right? Or I could have these kind of edges like that. Or I could have just these 2 edges and then a flying vertice. Or I could make this kind of fun thing. Or I could go back to just the regular square, right? But then put a diagonal. Or I could do a regular square and do 2 diagonals. Or I could do like this and this and this and leave this one side open. And I think that would be it. Whew. Okay, one more. 4 vertices, 3 edges. Doesn't say anything about being simple, so that kind of makes it harder. Okay, so let's just start. So 3 edges. So I'm just going to start by putting 3 edges in like a square. Then one of the edges I'll make a loop, and then I'll make those. Then I'll keep this vertex open, a loop, and then parallel edges. Or I'm going to put loops on 3 of the vertices. Or I could put this thing and then 2 loops on one of the vertices. Or I could leave that there. Let's see, what else could I do? Keep 2 vertices on their own and then do a double loop on one of them. Then I could put triple loop and then a vertex. Oh, and I have to have 4 vertices, right? So 1, 2, 3 little isolated vertices. Or I could do 2 parallel edges, right, between 2 vertices, and then these 2 vertices just hanging out. Or I could do something like that. Or I could make a triangle and a dot. Or I could do a loop and a line between, or an edge between 2 vertices. Let's see, I could do a double loop and a single loop and 2 isolated vertices. Oh, here we go. We can make a little happy face. So we could have 3 parallel edges. Or I could have 2 parallel edges. Looks like a mad face. Or I could have this. Or I could have this. And then last one, couple of eyes, and there. I think that was it. I would never give you one this challenging on the test, I promise.